Okay, class, let's take a look at another confidence interval example. This time we're going to go back to the speeding cars. Let's suppose we take a sample of about 30 cars, and of those 30 cars, 72% of them were speeding. And we want to find the 90% confidence interval. We took a 95% confidence interval in the previous video, and that we needed a z-critical value of 2. We're going to find out that it's actually not exactly 2 standard deviations or standard errors for the 95% confidence interval. And we need to figure out a way to find the value for a 90% confidence interval as well, and I'm going to show you that. So we're going to look at the exact same initial setup for the 95 or for the confidence interval. For any confidence interval, we're looking at this scenario. Confidence interval is equal to p hat plus or minus the z-critical value times the standard error. The question now becomes, what is this z-critical value? To answer that question, I'm going to take you here to a t-table. We haven't learned about a t-distribution yet, but it kind of looks like a normal distribution, but there's a slight difference. However, as the sample size increases, the t-distribution becomes more and more like a normal distribution. In fact, if the sample size approached infinity, then the t-distribution would actually be equal to or identical to the normal distribution. So for reasons we'll get into, we look at the bottom of the t-distributions. We'll get into this later on in the course when we learn about t-distributions. But for now, you just need to know that we look to the bottom of the t-distribution to find confidence levels. So you can see we learned about the 95% confidence level or interval in the previous video, and we used the number 2. Well, that's kind of a beginner or rookie move there. We really shouldn't be using 2 for our z-critical value for 95% confidence. We really should be being a little bit more precise and using 1.960. So from now on, if you're doing a 95% confidence interval, you'll use 1.960. We're not doing a 95% confidence interval. We're doing an 80 or 90% confidence interval this time. So we should be using this z-critical, 1.645. If I asked you for a 99% confidence interval, we'd use 2.576. So you can always look to this table to find your z-critical values. So back to the problem. Now we can see where this next line comes from. Our formula becomes p hat plus 1.645 because we want 90% confidence times the standard error. Plugging in our values, p hat is 0.72, 1.645, plugging in for standard error, we can go to our calculator now and we can just type this thing in one fell swoop. 0.72 plus 1.645 times the square root of 0.72 times 0.28 divided by 30. And there's the upper end of our upper limit for our confidence interval. If I hit second enter, and I'm going to hit second left arrow to jump to the left side, make this a minus sign. And there's the lower limit of our interval. So now we have a 90% confidence interval. In other words, we're 90% confident that the actual proportion of speeders on this highway is somewhere between 58.5% and 85.5% of the vehicles are speeding. Our sample only showed 0.72. We know just due to regular sampling variability and the central limit theorem that this value could have missed the mark by a couple of standard errors. We just took into consideration exactly how many standard errors we wanted to kind of wager on this one. We only wanted 90% confidence, so we didn't move quite as many standard errors away. If we wanted to be more confident, we'd have to widen the interval to increase the confidence that P, the population proportion, will be captured by this interval. As it stands right now, we're 90% confident that the population proportion or the proportion of speeders on this highway is somewhere in between these two values. Where between those two values, we're not sure, but we're 90% confident it's there. Like I said, if we want to switch it up and look at a different level of confidence, just look to the bottom of this t-distribution. This can be found on the exam formula sheets. It can be found in your textbook. You'll start to get used to using some values like 1.960 for 95%, 1.645. Those are probably two of the most common confidence intervals that we would use. If we're using one that you're not sure about, look to this chart. there'll be a link to this on Schoology as well. So hopefully that presentation helps, and you have a pretty good feeling about confidence intervals.